Okay, guys, so this is the fourth installment in our series. So just two more to go. This time, Steve's going to be talking about Java EE and Jakarta EE doing microservices, because there's this idea that they're not suited for it and that they're more for monolithic architecture. But he's going to talk about why that's not true. So he'll introduce microservices themselves, what they're all about, as well as the JAX-RS API, and how that makes it easy to develop applications that use REST architecture, deployment models for microservices, and how to use MicroProfile with Jakarta EE as well. As usual, if you have any questions, please put them in the chat or put them in the QA section, and I will get to them as soon as I can. We will have plenty of time for questions at the end as well. So if we're all ready to go, Steve?
Okay, thanks, Jaden. Hi, I'm Steve Millidge. I'm the founder of Payara, and as Jaden says, I'm going to do one of the Myth series talks to talk about Java EE and microservices. We've been doing this as a part of a series where basically taking myths about Java EE that get put out there and looking at them in a bit more in depth and see whether they're true, given their myths are obviously not. So we're on the fourth now. So we're looking at Java EE and microservices. We have another couple to come. We've covered cloud native, whether the application servers are heavy or whether Java is an old and outdated API set. And the next one will be around standards, and then we're looking at the deployment model. So we're doing these on Wednesdays. So every Wednesday, same time, same place. We've got a webinar. So the next one will be about standards. So if you're interested in, how Jakarta EE, how Java EE went into Jakarta EE, and how Jakarta EE, what its relationship is with MicroProfile, and how you get involved in standards, that'll be next week. And then finally, the last one will be around deployment, and we'll also basically summarize a lot of what's been said in the previous webinars. So we'll sort of round it all up into looking at how Java EE deploys applications and how that's suitable for many different modern architectures. So, as I said, this one's around microservices. So let's basically dive in. The first question is, what are microservices? So this is one of the original definitions. This comes from Martin Fowler back in 2014. So we're talking, already 7 years ago. So this isn't totally new. It's actually, microservices are an evolution, to be honest. I haven't got time to go into the history of service architectures from RPC and things like that, but obviously there's been an evolution from remote procedure calls way back in the sort of 80s and 90s through Corba, which people may have heard about, and then remote EJBs in the Java space through web services, service buses, SOA, and RESTful architectures, and now we've arrived at microservices. So let's explore a little bit about the definition of what is a microservices. So effectively, in the Martin Fowler definition, it is an architectural style. So we're talking about how to architect applications, not necessarily, about the individual code and how you write business code. It's really about how you architect the system. And what you're doing is you're taking what people often call a monolith or monolithic application. So one application that is one big lump, and splitting it up into a suite of small services. Small obviously isn't defined, and as you go into architecture discussions, you can spend weeks arguing about what is small and what's the right size. But effectively, you have a suite of services. Typically, they'll all be running in their own process. So each service will run in its own process on the operating system, and they will communicate with lightweight mechanisms, typically HTTP. So it's very linked with the movement to REST APIs over, say, web service APIs. And the idea would be to build each service around a specific business capability, which we'll see in the next slide, so that each one will be sort of manage its own domain. And then because these are separate processes, then they should also be independently deployable. So you can take one microservice down without affecting the suite of other microservices, which is unlike if, for example, if you had a big single lump of an application in a monolith. And then because they're independently deployable, there's also a link into automated deployment. So you could be able to potentially roll out these independent automatically if you do an update to that service. None of that you sort of get for free, but it's part of the architectural style. And it's sort of the move to microservices is gone hand in hand with the evolution of how compute infrastructure works. So last week we looked at cloud native. If you weren't on that webinar, but we had a slide which I was going to repeat, but then decided not to, which basically shows how compute, so basically the physical or the hardware that you run your application on has changed, obviously, in the past 10, 20 years. It's gone from, you would previously deploy on a physical server through deploying onto a hypervisor and through a virtual machine. And then nowadays we're talking about deploying onto containers within a container orchestration platform. And this sort of goes hand in hand with microservices, because what we can do is we can package up a service into a container and then deploy it automatically onto some compute infrastructure. So the whole of these trends sort of come together to form what's sort of called microservices. Obviously, you don't have to use containers with microservices. It's not one of those things that is required, but it helps with the automated deployment machinery piece in this definition. So what would this look like typically? So here's sort of a typical example that people like myself make up to talk about what microservices architecture. So if you imagine perhaps you had an ordering section of an e-commerce website, or you were selling stuff online, and you needed to take the various business domains that are associated with that. For example, we have billing, so that's a very specific business domain. It could involve credit card payments, raising invoices, things like that. What we could do is take that business domain and build a microservice or set up or a number of operations in a microservice that would serve the billing domain. And within that, you would potentially have a REST API, and each would also have a load balancer, so you can independently scale this microservice out, and it would potentially have its own data store or persistent store for its own business data. And similarly, you would have the same for inventory. So if you needed to obviously work out how much stock you have, then potentially you'd have an inventory service as well that would talk to a stock database, work out whether you have things on hand or whether you need to order them in or something like that. And then basically you would take your application and you would split it down into these business domains. So for example, we've got search there, and potentially we could have warehousing for when something gets shipped, so you could send it off to be shipped, picked and shipped, and also update the stock database. And in this illustration, one of the things to pick out is, microservices will typically be via REST. It's not required for basically retrieving data or updating data. Or however, they can also talk through messaging streams or general message-oriented middleware, maybe like a JMS, or if you're into streaming, something like Apache Kafka or some other streaming technology. And they can also update microservices through the same mechanism. So they could take event streams, update the stock database from warehousing, and keep that up to date. So I haven't got a slide comparing with a monolithic application, but typically, if you thought of it as a monolith, you'd build all these in a single deployment module, potentially, and we'll come and look at that as well. So the idea is, we split it out. These are very well-defined business domains. Each microservice does one thing and does it well, and each one could be developed by a separate team, which we'll come into. And they would tend to have a separate domain database. So it's not just about your service architecture, it's also about your data architecture. Each database would be associated with one or more microservices and be very specific to a specific business domain. So similarly, you wouldn't have a big monolithic database schema. And a lot of, again, part of this also is follow the evolution of the user interface technology. Nowadays, we obviously build a lot of UI for web applications using JavaScript frameworks. what this allows us to do with a microservice is you can obviously call from a JavaScript multiple of these REST APIs and then assemble and render a user interface that maybe fuses data from each of the different services or many different services. In sort of before we did a lot of client-side rendering and user interfaces, we would do server-side rendering. And obviously server-side rendering is much more difficult if you had a microservices architecture, because you'd need to then do a lot of the calls on the server side from a something like JSF or something that or Wikit or some other server-side rendering framework, whereby you would be pulling data from various services, making it into HTML and throwing it to the client. So again, microservices has evolved to be complementary to that JavaScript frameworks. So that's why I would see it as a typical microservice architecture. I mean, your challenges from an architecture point of view are actually working out what these business domains are, what the services are, what the what constitutes a microservice, whether that microservice should be in this domain or another domain, whether you should create 1,000 microservices or 10. But these are all sort of architectural questions that have been there from the beginning of time, really. It's how you split up your requirements and your business domain into good piece components of software. So what are the advantages of building microservices or building an application as a set of microservices? The first is modularity. If you're doing something that's a well-defined domain, like billing, then you can concentrate on that domain, make it modular, not closely coupled with other domains, so therefore you can analyze and break them down into pieces. Also, from a deployment perspective, each microservice is separately scalable. So, for example, on the previous slide, we had search. If you've got a lot of search traffic, then you could maybe fire up 10, 20 instances of the search microservice, while at the same time only having like one for warehousing or something. Whereas if you put it all in a single application, then you'd have to scale the whole application. It's not that a monolith isn't scalable, it's just more that it's not separately scalable. Also allows independent development, so you can also break your development team up, arranged around your microservice, so they can concentrate on a single or group of microservices. There's obviously challenges with that, in that often your architecture will reflect how you split your development team up. So you have to be careful to make sure that you're actually building your architecture around how you want to split your microservices. Each one can be independently deployed. So you can take the search service and you could deploy it completely separately from the warehousing service. Whereas if you package that all into a single application, then you'd have to redeploy the whole application. And again, linked to modularity, I mentioned they can be more loosely coupled. And then they're also replaceable. So if you wanted search service version 2, then with great care, you could create a search version 2 and move that over and replace and strangle search service version 1. Again, this isn't something you'll get for free. You have to architect your interfaces to your microservice so that version 2 would comply to version 1. Otherwise, you would get coupling with different services would have to be updated too. So you'd have to still architect that capability. Each one should be highly testable. As we'll see, testability, we're probably talking about unit testability of the actual microservice. It's highly testable. As we get into system testing the whole thing, then the complexity arises. The other one is they could be written not in Java, they could be polyglot, if that is something that you want to do in your organization or see as an advantage. And that also allows, again, small teams, so they can be independently developed, so they can have split into small teams. But one thing you have to watch, as I said, microservices is an evolution of architecture, software architecture, which has had a long history from all the way back into RPC. So there's some things you need to watch with a microservices architecture over, say, building it all in a single application. The first is something that's been around for a long time, originally from Sun in the 1990s, which is basically that you have to be worried about the fallacies of distributed computing. And I'm not going to go into each one of these, but basically, if you're splitting something up into a whole suite of microservices that are independently deployable, then you are building a distributed computing architecture. And therefore, you have to be concerned about distributed computing issues like, for example, the network is not reliable. So just because you, in the sunny day scenario, have search always being called, of warehousing or search calling another microservice, and that always works, because they're across a network boundary, it may not work sometime, and you need to handle those things. And we'll talk about some of the APIs that exist for around that. Again, latency is zero. Is zero. That is a fallacy, obviously. If one microservice calls another, if they were on the same VM and they were built in the same monolithic application, then that function call or whatever it is would be in microseconds. Once you start pushing it across a network, then it's obviously is now likely to be in milliseconds. So that's orders of magnitude slower. And you need to be careful about these things. So you need to be concerned around the trade-off between coarse-grained services and fine-grained services and those sort of typical engineering trade-offs. And again, there's a number of these which are basically about the fact that you're now across a network. So you have to be concerned about that when you move into microservices. And there are, like, say, APIs and things that can help, which we'll cover in a minute. So obviously, something is not all wonderful. Microservices have disadvantages over, say, just building an application as a monolith or a smaller number of coarse-grained services. First one's operational complexity. So even though each one's independently deployable, independently scalable on its own compute infrastructure, obviously that introduces a lot of moving parts. So how you manage that and monitor it becomes more complex. It almost scales with the number of microservices. So distribution we've talked about. Or we also talked about splitting up the database so that databases were not monolithic, schemas were not monolithic, but that can lead to issues around eventual consistency. For example, if you update the warehouse database, send a message to the actual ordering system to update inventory, and that message there's a latency to get there, then obviously the databases are out of date. And in fact, you could show stock when you haven't got any. Whereas if that was all in a single schema, then that would be unlikely. So you have to manage consistency issues. Again, around operational, there's obviously maintenance complexity as well. You can build terrible microservice architectures whereby you do get a lot of lifecycle coupling. So for example, if microservice 1 calls microservice 2, obviously we're now in a distributed situation. So what happens if microservice 2 isn't available? People who build microservice 1 need to handle that complexity within their application, a complexity that wouldn't exist if this was in a monolith, or because obviously that service would be deployed alongside the first one. And I've seen that in architectures before, where people build a microservice architecture and they have to start everything up in a certain order because they've not handled lifecycle coupling, and that again leads to maintenance and operational complexity. Unit testing or single microservice testing can be easier in a microservice. However, system testing across the whole thing becomes more complex simply because we have that distribution, we have eventual consistency issues, we have a distributed system. It's basically inherent in any distributed system that system testing is way more complex. And similarly with fault tracing, if you have a lot of, if something is bouncing events around a network and services are calling other services, well, obviously, if there's a fault, you don't just get a straight stack trace like you would get from monolith that has every service in. You need to trace and track across multiple processes, across multiple machines to work out what happened. And that can be something that's a bit of a disadvantage or a bit of an increase in complexity when you're building these things. In reality, you're more likely to end up in a situation that you have a combination of all different architectural models. You're going to end up with probably a monolith where for some application, some part of your enterprise architecture or your architecture, you're going to end up with something. you could call a macro service, or something that has multiple microservices deployed together. And you could have microservices for different parts of the architecture. In reality, none of us live in a green field, or have a green field to start with. So we need to work with what's there in an organization and build applications around that. And also, practically, as an engineer, as a software engineer, or as a software architect or technical architect, your job is actually to produce the most optimal solution that meets the needs of the organization, not to slavishly follow some architectural paradigm or architectural pattern. So maybe that for efficiency, you want to, or whether it's even operational or performance or whatever, you may want to group a bunch of microservices together, deploy them together. It may be that, you might want to do server-side rendering, or you might want to create a specific monolithic application because that's the most efficient for your use case. For example, if you don't have large teams and you're not needing to independently scale services, and you don't have thousands or hundreds of thousands of users or spikes in traffic, then some of the disadvantages of microservices come into play and may outweigh some of the advantages. So you just, as an architect, your job is to track the right course. So typically we'll see lots of different ranges from microservices through monoliths. Okay, so that's the architecture, but what about the APIs? So as we said, typically when we're talking microservices, this is very typically associated with REST APIs. So obviously Jakarta EE or Java EE has Jakarta REST. It has a standard REST API for building RESTful web services. It's used in other frameworks, things like Dropwizard and things like that use the same APIs. We have data transfer, so we can support JSON. As I mentioned, typically many REST web services for a user interface will be talking to JavaScript and passing and moving data across the network through JSON. So Jakarta EE has standard APIs for JSON processing, JSON-P, and JSON binding, which is mapping objects to JSON, has standard APIs for that. We have CDI, which is a dependency injection framework in Jakarta EE for building your business logic. And then from the transaction side and through the integration to data, we have standard JPA. Hibernate, for example, is a JPA implementation for mapping Java objects to databases, and we have JMS for messaging, and something that doesn't come up very often, JCA, which is a connector architecture, which can be used to build connectors to other systems to send messages around through different messaging type systems. For example, in Payara, we have a bunch of standard JCA connectors for different cloud messaging. So you can deploy Kafka or Amazon SQS as your service bus, MQTT. So you can talk to these different things that are not JMS compliant and send messages or event streams across different technologies. MQTT, for example, is focused around IoT. Kafka is focused around event streaming and event persistence. And all these things can be integrated with Jakarta EE applications. So we do have all the APIs that you can to build microservices. So how would, in Jakarta EE, how would a microservice typically get deployed? So as I mentioned, the microservices architecture works really well with containers. This is because you can take your microservice, package it into a container which packages the application configuration, and then you can deploy it onto some cloud container service either, or a container service like Kubernetes, or other more raw level around Docker or something like that. So Jakarta EE, as we've seen in some of the other webinars, has evolved completely from only supporting sort of domain style application deployment through into runtimes like Payara Micro, which is a single jar, and you can package up a microservice as a WAR file on top of Payara Micro, and then push that on top of a JVM, on top of an operating system, wrap it in a container and throw it at a container service. And that could work on as I mentioned, things like Amazon Elastic Container Service or Azure Container Instances, or it could run on your data center on something like Docker. And you can run multiple containers, obviously, into a single machine or single VM or whatever you choose to run it on for a compute. And these can be independently scalable. So your container service can scale out the microservice, the container instances, and that would scale out your Jakarta EE microservice, just like we need as we need for microservices architecture. And they can be obviously automated deployment and all those things. It gets the same as any other technology that will sit in a container. And there's some advantages of Java EE microservices or Jakarta EE microservices over, say, other just sort of fat jar type technologies, in that when you are building containers, you build them in multiple layers. So a layer is a bit like a configuration managed layer. So typically you would have your base operating system layer, and then we have the managed runtime, or in our case, it'll be a Java EE, Jakarta EE runtime like Payara Micro, and then you package your microservice on the application layer. And because your microservice changes more rapidly than the runtime, which can be versioned and sort of standard across your organization if needed, and that has probably only needs to change when you need additional security patching or something like that, then your changes in your application, they'll be quite small because your application will be quite small. And that allows that you can then push out containers across the network faster, because most of the container technologies just push change sets across when they deploy new versions. So we can rapidly deploy new microservice versions through just changing the application layer. And this again scales onto Kubernetes. So briefly talk about this. I mean, Kubernetes is a platform for managing containers at scale. Typically works on basically containers, and a pod, which is a definition of a sort of service, a microservice, along with its container image that it will run, and you can then scale out pods and scale them out, scale them back, do that independent scaling from microservice. And you can do that with Jakarta EE and things like Payara Micro. So you can also support modern infrastructure architectures like Kubernetes, or infrastructure technology like Kubernetes. We've seen one of the other questions we had before is, well, that's all well and good that you can create a container for a microservice in Jakarta EE, but Jakarta EE is really big and heavy, and we had a webinar about this at the beginning. So this is just a quick image heap dump of a Payara microservice, Payara Micro running a microservice in Jakarta EE, and you can see that Jakarta EE is not heavy technology for microservices. This JVM is only using 44 megabytes of heap. So it's very easy to package up a Jakarta EE application into a container, deploy it as a microservice, or deploy Jakarta EE microservices using those APIs. So Jakarta EE is very small, can be packaged in containers. It can do all the things that you need for a microservice. It has REST APIs. You can build applications, and you can talk to databases and messaging infrastructure that you need to do. In addition to Jakarta EE, there was an initiative, which again, I'll talk about more next week in the next webinar, called MicroProfile. And MicroProfile is another set of APIs that is explicitly tracking the challenges of a microservices architecture, and it builds on top of Jakarta EE APIs to provide some of the things that help, in deploying and running a microservices architecture and building microservices. So Jakarta EE APIs it builds on top of is the ones I showed in the other slides. For example, JAX-RS, Jakarta REST, JSON processing and CDI. And then we have some specific APIs that help in that architecture. So for example, open tracing. One of the things I mentioned is it's very difficult. It becomes more complex to debug and trace what's happening in a distributed system. Open tracing provides APIs where you can build traces of remote calls and get them for debugging purposes. There's fault tolerance, which allows things, as I mentioned, the fallacies of distributed computing. Fault tolerance allows you to add annotations to a service call, whereby if you try and call this remote service and it's not available, then you can provide fallback to a different service, or it has APIs for retrying and doing things like bulkheads to limit the level of concurrency you're getting through your service. So it has a lot of that API set that helps in that mitigating the issues of having distributed architecture. There's a REST client, which simply is what it says. It's a client API for calling other REST services. Open API, which is basically defining REST endpoints and JSON documents. Config gives you externalized config, so if you're deploying containers, they can configure themselves from external sources like Kubernetes secrets or other sort of external config. It could be a database, could be a directory, it could be many different things. And so there's APIs to build and deploy those. And these can all be built on top of the Jakarta EE APIs. And then there's metrics, which is for monitoring. As I said, monitoring becomes operational complexity increases, so you need ways to gather all the metrics from different things and different services and consolidate them into some centralized system, maybe like Prometheus or something. And metrics API allows you to build business metrics. And health basically is a very simple API which allows you to expose whether your service is alive or dead, and that enables other services to decide what to do, and also for container orchestrators to decide to kill or restart your service. And then the security ones like JWT, JSON Web Tokens. So you can see there's a whole bunch of extension APIs on top of Jakarta EE and MicroProfile, which is explicitly for building and mitigating microservices architectures. And MicroProfile is a multi-vendor initiative. These are all different types of implementations. So we have things like Wildfly and Quarkus from Red Hat, Helidon from Oracle, Payara Micro from ourselves, OpenLiberty from IBM, and Apache Tommy from Apache Foundation, and Launcher from Fujitsu, and Cumulus EE from the Cumulus team. So these are not just Payara APIs, these are industry standard APIs that we're generating. So to summarize, basically Jakarta EE and MicroProfile can easily deliver microservices. They are small, they have many APIs on top of Jakarta EE. Jakarta EE provides a foundation, MicroProfile provides extensions specifically for microservices architectures. And we can build these into small containers, deploy them, and have all the characteristics of a microservices architecture using Jakarta EE. So, if you go on to any questions, thank you for listening. Jaden, any questions?
Thank you very much, Steve. Yes, we do have 2 questions. The first one from anonymous attendee. However, he does frame that this question may be out of context a bit, just to preface it. It asks, did Java EE microservices copy Django framework apps model? If so, why does JSF as a web framework not copy Django models and view usages by also adding an admin configuration page?
Okay, so I have a problem answering that because I'm not familiar with Django. So I can't really answer the question.
Yeah, because I think it's Python's web framework.
Is it?
Yeah,
yeah, I don't know.
Okay.
So I mean, if we don't REST, most of it will go through JavaScript frameworks. So I'm not familiar with Django.
Okay. The next one is from Daniel Poplowski. He asks, could you briefly describe the main differences between usage of Spring versus MicroProfile? Big question.
Again, I'm not a big, I have a lot of knowledge on Spring now. I do have some. So Spring obviously creates its own APIs for these different aspects. Some of them are related to Jakarta EE. For example, Spring uses, some Spring uses Hibernate heavily, doesn't have to because it has different data APIs. I would say they are comparable. So they are different, but they're all trying to solve the same things. Spring has a lot of dependency on Jakarta EE APIs in the foundations of it, but it does things in a different way. The biggest difference, I would say, is that Jakarta EE is a multi-vendor initiative, and therefore it's supported by multiple different vendors in the industry. So the way the APIs are developed is different in the sense that they are through collaboration, and sometimes that can make them slower to do. And again, I'll talk about that in standards, slower to innovate, but at the same time, the longevity of the APIs is there. You know, they stay for a long time, and you can choose which runtime. For example, you could write a microservices in Jakarta EE and deploy to Payara Micro, and then if you didn't like Payara anymore, you could maybe deploy some of them on Open Liberty or something like that, or vice versa. Or you could mix and match if you wanted to in your architecture. And then another bit I touched on, the difference would be how you deploy. So we can deploy thin wars in different layers, whereas typically in Spring, again, I'm not a Spring expert, so you would typically deploy it as a Spring Boot fat jar or something like that. But then again, I'm not up to speed on Spring, so don't kill me for it if you like Spring.
Victor has a question as well, and he asks, what will be the pricing of Payara Cloud compared to AWS, Azure, etc.?
Well, it runs on top of, it runs on top of Azure. It'll be comparable to something like Azure's Spring service, going back to Spring or something like that. Typically, you will get a set of compute power for a certain price, and you will be able to deploy as many microservices as you want, or Jakarta EE services as you want onto that compute. And it'll be basically pay as you go, typically on a monthly basis. So that's how it will be. It'll be obviously more expensive than raw VMs because we sit on top of raw VMs from Microsoft Azure and Kubernetes. So, but yeah, it'll be comparable in a sense. It'll be monthly bill and all that sort of thing. So,
okay, awesome. And that is all the questions we have at the minute. If anyone has any other questions, please feel free to put them in the chat. Otherwise, you can always head to our website and you can get in contact us through our email or our socials as well. We'll do our very best.
Okay, and next week we're talking more about standards. So we're looking more about into Jakarta EE, how that's developed, how it works, how the whole foundation side of it works, if you're interested in those sort of things, and MicroProfile as well, and how the working group operates and the relationship between them, and how you can get involved in actually driving forward these APIs and these standards. So
fantastic. In the chat as well, I'll put links to the Dismissed in this page for further info, and they also have links to the videos from the previous sessions as well, where we'll be uploading them on YouTube. There's also a meetup page where we put notifications up of further events if anyone is interested. But if that's it, thank you very much.
Thank you very much. Thanks for your time.
Thank you. Bye.